Alright, so the last topic of our unit is hyperbolas, but we're going backwards writing equations. So it's similar to the ellipses, where we're going to use our focus, our center, our vertices, and our asymptotes to help us figure out all the different parts that we need to know. So just a reminder, our general form of a hyperbola is either x minus h squared over a squared minus y minus k squared over b squared equals 1, or y minus k squared over b squared minus x minus h squared over a squared equals 1. So similar to the ellipse, it has to always equal 1. And this is the one where the letter that comes first, the variable x or y that comes first in our equation, is the direction that our hyperbola is going. So that's going to help us determine which form we're going to use. So in our first example here, we're going to be given the vertices are 0 and comma plus minus 3, and our foci are 0 comma plus minus 6. So in a way that's very similar to how we did the ellipses, I'm going to do a little sketch to see what exactly I have. So 0, 3 and 0, negative 3. Those are my two vertices. Okay, so what that's telling me is that I have a vertical hyperbola, which means I'm going to use the second equation. So y minus whatever k is squared over b squared, and then x minus whatever I find for h over a squared equals 1. So I can write the outline of what my answer is going to look like. Now for the number that comes under here, actually let's do the center first. My center is halfway in between. So what's halfway between 0, 3 and 0, negative 3? That would be 0, 0. So I can put zeros here. So there's my center. The distance between the center and the vertice, this here is a distance of 3. So I'm going to have 3 squared underneath my y. So now I just need to figure out what my a squared is. Well, we are going to use f, because I haven't done anything with f yet, and they never give you information that you don't need to use. So if I go and plot my f here, I know that this distance is 6. So if I use the f squared equals a squared plus b squared formula, I have my b squared, it's 9. I'll have my f squared, that'll be 36, and I can solve for a. So 36 equals a squared plus 9. Subtract 9 and we get 27 equals a squared. Well, that's what I need to know here. So all I need to do now is rewrite my equation with a 9 on the bottom, 27, and I don't need to write those zeros. I can just write them as y squared minus x squared. And you have your equation. So a lot of it is the same as we did with ellipses. We're just using the hyperbola formula for focus instead. But a lot of those other pieces, we do the exact same thing we did with ellipses. All right, let's try one where we're given the vertices at plus minus 1 comma 0. And we're given the asymptotes as y equals plus or minus 5x. So again, I'm going to start by sketching what I know. So I know my vertices are at 1, 0. And negative 1, 0, meaning I have a horizontal hyperbola. So this is going to go x minus whatever h is squared minus y minus whatever k is squared equals 1. So now I'm just going to fill in the pieces as I find them. So my center is what's in the middle, so that would be 0, 0 again. The distance between the center and the vertice is 1, so that means this will be 1 squared. Now we have the asymptotes. So I know that my asymptotes have to have a slope of 5 over 1. So we have our slope is always b over a. So if b over a, we know that a is 1. So if we cross multiply and solve, or on this one it's a little bit easier because we can just match numbers. The only issue is sometimes this is reduced, so we would want to cross multiply and actually solve for b. But here, if we cross multiply, we just get b equals 5. So that means we would have 5 squared that goes underneath our y. So last step, just to clean it up a bit. So we can square our numbers and drop our 0, 0 in our equation, and we have our answer. So when you're given the asymptotes, you're really going to be using this b over a for your slope. And you only really need to do it with the positive. You don't need to worry about it with the negative, because that plus minus came out from the square rooting, not from necessarily the numbers themselves. All right, I wanted to do one more example here, and we're going to do vertices and foci again. So if one vertex is at negative 2, 1, and the other one is at 2, 1, and the foci are at negative 3, 1, and 3, 1. So right away, what's different about this one compared to number 1 is that I'm not centered at 0, 0. So this one is going to be not centered at 0, 0. So I'm going to sketch what I know. So my vertices, negative 2, 1, and 2, 1. So when I look at the relationship between my vertices, it's a horizontal relationship. So I know that it's going to be x first. So I can write the outline of my equation. And then we'll fill it in as we find our pieces. So when I look for the middle of my two vertices, that'll be my center. So my middle is right here on the y-axis at 0, 1. So I'm going to plug 0 and 1 in for my center. Now the distance between my center and my vertices is 2. So that's going to be 2 squared for my a squared. And then for the foci, we have negative 3, 1. So that's going to be here. And 3, 1, which is here. So my f is the distance between the center and the focus, which is a distance of 3. So I know that f is 3. So I can use that same formula, f squared equals a squared plus b squared. So we have 3 squared equals a squared plus b squared. So 9 equals 4 plus b squared. So 5 is equal to b squared. So now I just need to clean it up a bit, drop the 0 and square the 2. So that'll be x squared over 4. And here we'll have y minus 1 squared over 5 equals 1. And there is your equation. Okay, so what I'd like you to do is come back with any questions on how to write the equations, so in other words, working backwards, that you might have. We're going to do one more in class where we're given a point on the hyperbola and the vertices, just so that you can kind of see how to do those, because I know there were some questions on that type from yesterday. We're also going to look at how to tell the difference between all four shapes based just on the equation itself, because that's a tool that we'll need to know for the quiz on Monday. So come with questions. Hopefully this is clearing things up a little bit, and we'll talk about it tomorrow.